Hello everyone, this is Dr. Mo Shiva, Professor of Electrical Engineering Department at California State University, Fullerton. Purpose of this video is to review superposition, and I'm assuming you're familiar with superposition and we just want to see a review. Kind of quickly, superposition states that the response being voltage or current at any point in a linear circuit caused by two or more independent sources is equal to algebraic sum of the responses caused by each independent source acting alone. The emphasis is on independent sources. We concentrate only on independent sources. So in this example, we want to find current I passing through the 5 kilo ohms on the top using superposition. We have three independent sources. We want to keep them one at a time. So initially, let us keep the 105 volt source, and we want to kill the other two sources. Kill means simply remove the effect of them. So if the current is zero here, that source is converted to an open circuit, and zero voltage on the right side, we replace the source by a short circuit. So keep the 105. To find I1, we notice that these two resistors are in parallel. So let's combine those and divide 105 by the total resistance. So I1 would be equal to 105, the total voltage. Total resistance is 5 plus 20 and 10 combined in parallel. So that would be 20 times 10 divided by 20 plus 10, 105 over 350 over 30, and we get 9 amps. Next, let us keep the current source. So we are keeping the source, short circuit the two voltage sources. Working on independent sources one at a time. To find I2, let us do a current division at that node. Current division gives us the current in the natural flow of the current. In other words, we get the current going left into the 5 ohm resistor. I2 is opposite to that, so I2 would be negative, total current is 14. Splitting it, again notice that these two resistors are parallel to each other, and that goes in the numerator. So negative 14 times 20 times 10 divided by 20 plus 10 divided by total resistance, which is the parallel combination, plus the 5 ohms resistor. This gives us negative 8 amps. And finally, going back to the original circuit, we keep that voltage source, open circuit the 14 amps, and short circuit 105. So this is our third circuit. To find I3, first let us find the current I, and then we can do a current division to find I3. Current I would be we have 70 volts. Now these two can be combined in parallel and put in series with the 10 ohm on the top. So divide 70 by 10 plus 5 and 20 in parallel. 5 times 20 divided by 5 plus 20, and that gives us current cap I. And next on the same line, let's do a current division. We are interested in current going into the 5 ohms. So put the 20 in the numerator, divide by 20 plus 5, and we get 4 amps. So according to superposition theorem, current I is I1 plus I2 plus I3, 9 minus 8 plus 4, and we get 5 amps. So that's basically superposition. Something which is important is superposition is only applicable to linear responses, such as voltage and current. Nonlinear responses, like power, are not subject to superposition. Let's look at an example for that. We have two independent power supplies and a 1 ohm resistor, as you see in the figure. So obviously V is 2 plus 1 equal to 3 volts. Current I, divide the voltage by 1 ohm, is 3 amps. Power is VI. Power absorbed by the resistor is 9 watts. And next, let's do superposition. Keep the first source, the 2 volt first. V1, call it V1 now, is 2. I1 is 2 divided by 1 ohm, 2 amps. P1 is 2 times 2 equal to 4 watts absorbed. Keeping the next source, the 1 volt at the bottom, V2 is 1, I2 is 1 over 1, and P2 is VI 1 watt. Compare these results to the correct answers that we have for the original figure. We notice that V is 3 is equal to 2 plus 1, which is V1 plus V2. I is 3. That is 2 plus 1, I1 plus I2. So as you see, superposition works. for linear responses. If we look at power, the correct answer is 9, and it is not equal to 4 plus 1, which is 5. So P is not equal to P1 plus P2. Superposition does not work for nonlinear responses. I will do another video for superposition, and we will include a dependent source in it just to see if it is worthwhile doing superposition when we have a dependent source. Please watch that video later. Thank you.